Hello, I am JD and you're listening to The Ongoing. This episode is a bit longer and a bit more layered, but it is also one of the most important stories we have told so far. So, we are going to do this in two parts. In this part, we will look at how we learned to make electricity and store it. So let's begin. We use batteries every day. In our phones, in our laptops, in our cars. We charge them, we use them, and we charge them again. It feels completely normal. But this was not always possible. To understand how we got here, we have to go back. Before modern batteries, electricity was known but only as sparks, static charges, and sudden flashes. We could observe it, but we could not control it, we could not store it, and we could not make it last. In the late 18th century, an Italian physician named Luigi Galvani was studying frog legs. When two different metal instruments touched the nerve and the muscle of a dead frog's leg, the leg twitched. The frog was not alive, but the muscle moved anyway. Galvani believed this was animal electricity, a natural force present inside living organisms. A few years later, another scientist began to question that idea. That scientist was Alessandro Volta. Volta believed the electricity was not coming from the frog, but from the materials themselves interacting through a chemical reaction. So he built a simple device. Metal and cloth stacked in layers, the cloth soaked in a salty liquid. Metal, cloth, layer after layer. And when he connected the stack, something remarkable happened. Electricity flowed. Not for a moment, not as a spark, but continuously. For the first time, we could create electricity on demand. Around the turn of the 19th century, this became the first practical battery, a device that could produce electricity in a steady and controlled way. But Volta's battery was just the beginning. It proved that electricity could be created continuously using chemistry. Over the course of the 19th century, batteries became more stable, more reliable, and easier to use. They began to move out of the lab and into the real world. They started powering early systems, signals, and communication devices. For the first time, electricity was not just something we could observe. It was something we could use. At a simple level, a battery works because of chemical reactions inside it. It has two sides, each made of a different material. On one side, the material gives up electron more easily. On the other side, the material accepts electrons. When you use a battery in a device, electrons leave one side, travel through the wire, and reach the other side. That flow of electrons is electricity. At the same time, inside the battery, atoms that lose electrons become charged. Those charged atoms are called ions. These ions move inside the battery from one side to the other, while electrons move through the wire. These two movements happen together. That's what keeps the battery working. So at its core, a battery uses chemistry to make electrons move, and as that happens, material inside moves from one side to the other. In non-rechargeable batteries, as we have just seen, atoms give up electrons, become ions, and move to the other side. These ions stay there. Over time, more and more of the material shifts in one direction. And once most of it has moved, there's nothing left to move. The battery is used up. These are the batteries you find in things like remote controls, wall clocks, and many AA and AAA batteries. In rechargeable batteries, when you plug the battery in, electricity flows into it. That electricity pushes electrons back through the system. Inside the battery, the ions that had moved to the other side start moving back. As they move back, they gain electrons again and return to where they started. So the material goes back to its original place, and the battery is ready to be used again. These are the batteries we use in phones, laptops, electric vehicles, and car batteries. So charging is not filling the battery. It is resetting the system, bringing everything back to its starting point. Batteries made electricity portable. Instead of being tied to a fixed source, you could carry it with you. Over time, another way of generating electricity also developed. Large systems where machines generate electricity, spinning turbines, driven by steam, water, or wind. That's the electricity that powers our home today. But batteries were different. they used chemistry to create electricity in small portable systems. They could work anywhere without wires, without large infrastructure. And as devices became smaller, more portable, and more powerful, the batteries had to change too. The old batteries were not built for that. They were too heavy and did not store enough energy for their size. And making them bigger was no longer a solution. Something had to change. We needed a different approach. Not just a better battery, but a different kind of battery. A material that could store more energy without adding weight. A material that could move back and forth reliably. And that material was lithium. But using lithium would turn out to be far more complicated than it seemed. In the next episode, we will talk about how that problem was solved. Thanks for listening. I am JD and this is The Ongoing.